Isaac Newton's third law are in fact also at the same time the second and the first law, because the third law describes a perfect equilibrium. In this example we are speaking about fields, electric fields and magnetic fields. And magnetic fields have no location. They are not positioned at a certain point. So for the interaction between fields, you have no other option than to choose for force densities expressed in Newton per cubic meter. That means that the requirement of Newton, the third law, is in fact a universal leitmotif, which is a property of this reality. When you're born, you enter this reality, this world, and when you die, you just leave this reality, this world. But as long as you are in this world, you have to be part of the rules of this world. And Newton was very special because he was simple. He did not have creative ideas. That's one of the problems in physics, that they're all creative scientists with creative ideas, and they're very intelligent, very smart and very good in mathematics, but it's their own idea. And physics is not a collection of ideas. Physics is just the real world, what's really existing, and that is already there. All you need is somebody who observes nature and learns from nature and passes it on. And Newton has passed on what he saw and what he's learned from nature to the world in the third law. A perfect equilibrium, the leitmotif of the universe. And it means that nothing in this world cannot exist. It's impossible that it exists if it's not in a perfect equilibrium with itself and its surrounding. That is for fields, that is for particles, that is for galaxies, that's for the whole universe. Everything in the whole universe is just fulfilling one leitmotif, and it's a leitmotif of equilibrium in every direction, at any location, at any time. And it doesn't matter if it happened 8 billion of light years ago or it will happen in the future, it's the same law. It will never change. And that is why this law is so powerful. And what we will see now, if we do the calculations, that indeed for a phenomenon like an image of the beginning of the universe, which travels for 8 billion years over a distance of 8 billion light years to the Earth, could only reach the Earth, could only reach the James Webb Space Telescope, because during all these 8 billion years the image has been in a perfect equilibrium with itself and its surrounding. We will see when we calculate the force densities in every direction, at any location, at any time, that always the sum of all the forces, the electric forces, the magnetic forces, the inertia forces together, will be always zero. And that is the power of this leitmotif. It is always true, it's always the rule, it will always happen. Nothing can exist in this world if it is not fulfilling this leitmotif. A perfect equilibrium, zero of the sum of every single forces in every direction, at every location, at every time. Now we start with the calculations, and we will see that we start with calculating the force densities in Newton per cubic meters, and we will pass on till we have finally found the total net sum of all the forces in all the directions, at all the locations, at any time, of an arbitrary picture. Because we do not know how the beginning of the universe looked like. It has to be an arbitrary picture. A picture which can be anything. And we choose this in an XY plane, and it's propagating into the Z direction. And we will see that the speed of propagation is fundamental. There's only one speed which allows this image to propagate through space without changing, without falling apart. Because there's a huge difference between sound waves and light waves. Sound waves are just waves of a sound pressure. It's just the pressure and okay, this propagates in every direction. You can never make real images with sound waves. You can find something like shadows, but it's not very much. But if you look at light, it's very different. It's fundamentally different. Light is a totally different phenomenon because it has the power to confine itself. You have in a beam of light not only power which in fact radiates in every direction, the radiation pressure, but you have also the confining forces which holds it together. That's the power of light. Light keeps itself together during 8 billion light years, and that is in fact miracle, but it's the law, it's the leitmotif in physics. And when we look at these equations, we will see that there is a perfect equilibrium between the radiation pressure and the inertia of energy that in fact determines the speed of light, and there's a perfect confining equilibrium between the radiation pressure, which wants in fact the beam of light to expand in every direction, and the confining forces, which are electric forces and magnetic forces, which keep the beam of light completely intact, unchanged for 8 billion years, and finally reaches the James Webb telescope. In fact, it's a miracle, but it's happening. And this equation is the only equation in physics which describes this beautiful, wonderful phenomenon. To do the test, you go to the website Quantum Light Science. And then you will see this site appear, and you scroll down. You scroll down until you see the top of the equation we're going to use, and you choose example 1. And you have 3 possibilities. You can click on the PDF format, just download it like something you can read. You can click on the download the program itself, the next symbol, or you can click at the last symbol, and that is in fact a real print of the calculations themselves. The solution, the mathematical solutions for the propagation of light in quantum light theory. In this example, the problem we have chosen to test is in fact an arbitrary picture propagating over a distance of billions and billions of light years, being created billions of light years ago, and it stays unchanged, untouched for billions of years, and finally reaches the James Webb Space Telescope. You see here the equation, and you see even more. You see in green the interaction of electromagnetic fields with gravitational fields. This is the part we will choose when we move on to general relativity. We choose a Cartesian coordinate system, and in the XY plane the image of the beginning of the universe has been located, and this image is propagating with the speed of light towards our galaxy, towards our James Webb Space Telescope. And there's one thing we know about the image of the beginning of the universe, and it is that we don't know. So for the intensity function and the functions for the electric field intensity, magnetic field intensity, these are unknown functions, and they're arbitrary, totally arbitrary. So you can fill out for this function in the XY plane everything you want, but it always has to be a solution of or Newton's second law of motion applied to an electromagnetic field, or the Maxwell's equations. But it is very clear that if this function doesn't match one of the terms of the Maxwell equations, or the total term of Newton's second law of motion applied to an electromagnetic field, this will be impossible to be transported towards our James Webb Space Telescope. It's very high demand that we find an equation which will give solutions for every arbitrary function x, a dependent. And that is why this is a highest requirement you can expect from a mathematical system, that it will be giving solutions for every arbitrary function. This image has to be transported, and it has to be transported towards our own galaxy, to our own solar system, and towards our own James Webb Space Telescope. This means that we need a function which is changing with time along the z direction, because the z direction is the direction chosen for the propagation. We fill out the speed of propagation, which equals the inverse value of the square root from the permittivity and the square root of the permeability. This means that this function g t minus z square root epsilon square root mu is propagating through space, and the function g is here arbitrary. This means that while the galaxies in the beginning of the universe are changing in time, all these different images form a new function in time. The time-dependent arbitrary function g is here represented as also arbitrary, but there's one requirement, and it means that the velocity of propagation, which has been indicated by the term of the square root from the permittivity times the square root from the permeability, has to be a constant value. And we will see that only under this specific condition, that every arbitrary function f in the xi plane and arbitrary functions in the time interval always have to propagate with constant speed. And this is what we choose for the electric field intensity, EV, and the magnetic field intensity, MV. And these two values are vectorial functions of the electromagnetic field propagating towards our galaxy. And this is a very arbitrary function in the xi plane and as a function of the time. They are both arbitrary functions, and the essential requirement is that these arbitrary functions in the xi plane and time-dependent functions, which is also arbitrary, always has to be a solution of or either the four terms of Maxwell or either Newton's second law of motion applied to an electromagnetic field.